Hello mentors, I am Anshul and this is the enhanced version of my POC for Agentic API testing. So based on the feedback I got earlier, I tried to focus mainly on improving the usability and overall flow of the tool rather than just adding more and more features. The first thing I changed was moving the AI testing option to the left panel. Earlier it felt a bit intrusive, so shifting it here makes the workflow cleaner and also avoids interfering with the existing UI. I also deployed the backend on Hugging Face Spaces, so you can directly try it out without setting anything up locally. I'll be sharing the link in my PR description and YouTube description as well, so you can test it out yourself and see how everything works in real time. For this demo, I am using a sample library API. So right now I'll upload the OpenAPI JSON file and paste the backend URL. Yeah, once that's done, I can choose what kind of tests I want the AI to generate. For now, I've added options like functional correctness and edge cases. As I select these, I expect the prompt to be updating live. And if needed, I can also manually edit the prompt so there is full control over what the AI generates. Now I'll generate the test cases. Just give it a few seconds. So yeah, the AI has generated a lot of test cases. Let's see the raw JSON file. Uh, just to be transparent on what the AI actually returned. But since raw JSON isn't very readable and API Dash is all about the user experience, I built a UI layer on top of it. So now you can clearly see what each test is doing, the expected status, and the payload being sent. You can also edit these test cases the way you want. Now, and you can select which tests also you want to send or remove. For so now let me run the tests. So as you can see, some tests passed and some failed. For the failed ones, the system also gives a reason on why they failed. Like for this case, email is already registered. So let me change this to John Doe 10 maybe. And let's try it once again. And yes, now it's completed successfully. So yeah, and you can also get the insight on why this thing returned this error. Yes, so as you can see, this error was caused because my API returned something which wasn't configured in the Open API where uh, a request was denied because that book was borrowed by someone else. So yeah, that's the whole case with the AI generated tests. Now coming to the second part of the demo, the agentic mode, which is basically the core USP of this project. So earlier what we saw was more of a predefined test generation and UI-based interaction of the whole Open API. But in this mode, we can actually interact with the API in much more natural way, like we interact with ChatGPT or any other tools, in, almost like chatting with it. Before I run anything, let me quickly show you how the system understands the API internally. As soon as I upload the Open API file, my batching algorithm automatically breaks it down into different functional groups. So for this API, you can see sections like root, users, books, and borrow. This is completely dynamic, so depending on whatever the Open API the user uploads, it will segment it automatically. Now, this becomes really useful because instead of sending the entire Open API every time, we can just work with the specific part we care about. So let me first show you what happens without context batching, which is my core USP of this project. So for example, now let me ask it something quite simple like return, get me the list of all the books. Yeah, so for this simple request, it required 898 input words, but which like isn't more. But with a large, very large Open API, this number is projected to be in thousands and thousands of words, which may directly incur more API costs where we can easily avoid it. So now let's try it with the OpenAPI context patching. And now I just have to get the list of all books. So let's try the same request once again. As you can see, it returned exactly the same output, but with just 393 input words. So that's the core idea behind this project, because this way we are basically getting the same output but with significantly fewer tokens. This directly improves performance and reduces costs and make it much more efficient, especially when running on local systems or using paid APIs. And yeah, that's the main idea behind this, making the interaction smarter by only sending what is actually needed. Now, coming to the another part of the project, here I am exposing my API test runner as a standalone component, completely independent of any Flutter dependencies. The idea is to make it act like a standard MCP server. As you can see, I have a connector named as API-agent. So to demonstrate this, I am testing it with Claude Desktop. So what I've done is I asked Claude to perform a few actions like checking the root endpoint, creating a new user with some dummy data, fetching the list of all books, and also inserting a random book of its choice. Let's see how it goes. As you can see, Claude Desktop is executing all these steps one by one. It's not just calling it a single endpoint, but actually reasoning through tasks and interacting with the API step by step. As currently, it just got a email already registered error, but it tried again with a different email ID. And now getting the list of all the books. Let's just give it a few seconds. Yeah, and adding a random book. Yes, as you can see, the Cloud Desktop. Sorry, as you can see, the Cloud Desktop returned uh, detailed responses on how it interacted with each of the requests. As you right now for this POC, the output is mostly in raw text format, but going forward, I plan to implement it a proper visual layer on top of this, so the results are easier to understand and everything works fine in a much cleaner and more intuitive way, as with the way of API Dash. So this demo basically shows how MCP can be used with a custom headless API test runner, making the whole system more modular and usable across different AI clients. Thank you.